Hi friends, welcome to my channel Belagali's class. My friends, for PUC second year 12th standard, almost I have completed the chapters inverse trigonometric functions, continuity, differentiability, application, even my friends, integration, everything I have completed, differential equations, vector algebra, everything I have completed, my friends. Now, my plan is just to do what? Examples under 1 mark and 2 mark questions. That 1 mark comes part A, which is a compulsory part. Part B, in that part B they give 14 examples. Out of the 14 you have to answer 10 examples. Therefore, these 1 mark and 2 mark questions, I will start once again with inverse trigonometric functions. In brief, I will explain the theory part of it. Means I will give the list of the formulae. Then I start doing the examples. Yes, my friends. I start with, this is my friend PUC second year or 12th standard maths class. I will start with inverse trigonometric functions. In brief, it is written as ITF. Inverse trigonometric functions. ITF. Yes, my friends. In this, especially, what is this year? This year is a special year. You can say Corona year. Here also, the effect of Corona is there for each chapter, my friends. Earlier, in inverse trigonometric functions, for the board exam, used to get one example under 1 mark question, 1 or 2 examples under 2 mark questions, 1 or 2 examples under 3 mark questions. Therefore, my friends used to have around 10 or 11 marks. But this time, with a reduced syllabus, number of questions are only 2. There is 1 mark, 1 question, 2 mark, 1 question. 1 mark question will be on definition or write the domain and range of ITF. Write the domain and range of ITF. These are the examples on that, my friends. Range of ITF means inverse trigonometric functions. This is 1 mark question. 2 mark 1 example here also. 2 mark 1 example. It is problems in finding the principal value of ITF. Problems on finding the principal value of ITF. Otherwise, clearly it is mentioned. Exercise 2.1. And worked examples means what? They are solved examples. Worked examples means they are solved examples. Solved examples, my friends. Solved examples. Is correct? Yes. It is. They have mentioned exercise 2.1 along with worked examples in the textbook. 1 mark 1, 2 mark 1. 1 mark 1 normally they have mentioned. Write the domain range of ITF. 2 mark question, problems on finding the principal value of ITF. It is made clear, my friends. Yes. What is the first question? First question is on domain and range of ITF. So I will give the theory part of it. This is domain and range. This range is also called by another name, principal value branch. Principal value branch of ITF. Yes, my friends, there are 6 inverse trigonometric functions: sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse, sec inverse x. This is the domain of sine inverse x. Either we can write in the form of what? Closed interval. The same closed interval, writing the same in another form. minus 1 less or equal to x less or equal to plus 1. Either you can write in this way or in this way, not both in this way or this way. This is the range or principal value branch I've written in brief. That is closed interval minus pi by 2 to plus pi by 2. Cos inverse x, what is the domain? Closed interval minus 1 to plus 1. Range, closed interval 0 to pi. For tan inverse x, it is an open interval minus infinity to plus infinity, or it is an entire set of real numbers. It is an entire set of real numbers. Open it is an entire set of real numbers. And what about the principal value branch? It is an open interval minus pi by 2 to plus pi by 2. For the cot inverse x, domain is same R. And what about the range? It is open interval 0 to pi. Cosec inverse x, it is the entire set of real numbers minus this open interval values between this minus 1 to plus 1. It is minus 1 to plus 1. This entire thing here and there except between minus 1 to plus 1. This is what? Range or principal value branch. It is a entire all points between closed interval minus pi by 2 to plus pi by 2 except 0. Pi till pi except 0. We know sine 0 is 0. What about the cosec 0? 1 by sine 0. It gives 1 by 0. 1 by 0 means what? It is infinity, which is undefined. Therefore, except this value, at this value, cosec inverse x is undefined to get infinity, my friends. Therefore, the range or principal value branch is closed interval minus pi by 2 to plus pi by 2 minus singleton 0. This is for the sec inverse x. Entire set of real numbers minus 1 to plus 1. Both are same. For the cosec inverse, sec inverse, the domain is same. And for the range, closed interval 0 to pi minus this singleton pi by 2. It is a set containing point pi by 2. Pi till cos 90 is 0 and sec 90 is undefined. Cos 90 is 0, sec 90 is undefined. This is for the principal value branch. This is for the domain of what? Sec inverse x. So, my friends, that 1 mark question is write the domain and range of this ITF. Therefore, this chart plays a very important role, my friends. This is very important for 1 mark question. Already I have done some examples here, appear many times in the question papers. See, 1 mark examples based on domain and range of ITF, that is, ITF is understood. First example, write the domain of fx equal to cos inverse x. My friends, it is appeared in March 2014. Solution. What is the domain of cos inverse x? That domain of cos inverse x is minus 1 to plus 1, closed interval minus 1 to plus 1. Second example, write the domain of fx equal to sine inverse x. It is appeared in J means July, M means March. It is July 2016. So the answer, domain of sine inverse x is, again it is what? Minus 1 to plus 1, or we can write the same interval in this way, either this way or this way, any one. Third example, write the range of sec inverse x. It is a very fresh example appeared this year, March 2020. Solution, answer is range of sec inverse x is this, my friends. It is a closed interval 0 to pi minus singleton pi by 2. This. Then the fourth example is write the principal value branch of cos inverse x. Write the principal value branch of cos inverse x. It is appeared twice, my friends. March as well as July 2018. What is the answer? The principal value branch of cos inverse x is closed interval 0 to pi. My friends. Yes, I give 1 minute. Copy it, my friends. Copy it. My friends, it is the next question. Write the domain of sec inverse x. Sec inverse x. So the required domain is R minus open interval minus 1 to plus 1. See here. For the sec inverse you wanted domain. For the sec and cosec it is same. R minus open interval minus 1 to plus 1. Next is write the principal value branch of tan inverse x. This is tan inverse x. This is the principal value branch which is open interval minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Next question is example number 7. Write the range of cosec inverse x. Write the range of cosec inverse x. This is cosec inverse x. You wanted its range. Range means this. It is closed interval minus pi by 2 to plus pi by 2 minus singleton 0. This is. Write the set of, see, little word is different. Write the set of principal value of y, principal value of y if sin inverse x equal to y. If sin inverse x equal to y. You mean you have to write what? The principal value of sin inverse x means principal value branch. What is the principal value branch of sin inverse x? Principal value branch of sin inverse x is minus pi by 2. Minus pi by 2 to plus pi by 2. It is what? Closed interval. It is a set containing minus pi by 2 to plus pi by 2. Otherwise you can write it in the set form. It is a set containing y such that minus pi by 2 lesser equal to y lesser equal to plus pi by 2. You can write the same in set form, set notation. Even otherwise if you write what? Closed interval minus pi by 2 to plus pi by 2, that will be also alright. Answer for this, it is little more appropriate, writing in the form of a set notation. Set notation. Yes, my friends, these are some 8 examples. They come under 1 mark question. They come under 1 mark question. All these 8 examples based on what, my friends? Based on domain and range of these inverse trigonometric functions. Inverse trigonometric functions. Yes, my friends. Then I do 3 or 4 examples, multiple choice questions based on domain and range. Multiple choice means objective type of examples. I do, my friends, some just sample examples, 3 or 4 examples. 2 are your textbook examples, another 2 little higher side. These examples have taken from your exemplar book, my friends, exemplar book. See them, I write all these 4 and I will explain it. Friends, these are some 4 examples, multiple choice or you can say objective type of examples. I have selected all these examples from the exemplar book, my friends. Exemplar book. Yes. The first question, which of the following is the principal value branch? I have written in brief. Principal value branch of cos inverse x. Cos inverse x. These are the options given, my friend. First option, closed interval minus pi by 2 to plus pi by 2. Second option, open interval 0 to pi. Third option, closed interval 0 to pi. Fourth option, open interval 0 to pi minus singleton pi by 2. Or you can say it is also closed. It is also closed. Minus pi by 2. Yes, my friends. Now for the cos inverse x, what is the range for the cos inverse x? The range is 0 to pi. Range is 0 to pi. Yes, my friend. Then which option is the answer? Third option is the answer. 0 to pi I have written. Third option. Next question. Which of the following is the principal value branch of cosec inverse x? Principal value branch of cosec inverse x. It is an open interval minus pi by 2 to plus pi by 2. Second, 0 to pi minus singleton pi by 2. This is third. It is a closed interval minus pi by 2 to plus pi by 2. This is open interval, this is closed interval. Fourth option, closed interval minus pi by 2 to plus pi by 2 minus singleton 0. 5. Cosec inverse 0 is undefined. It becomes infinity because sin 0 is 0. Undefined. Therefore, the correct answer for the principal value branch or range of cosec inverse x. Range of cosec inverse x is closed interval minus pi by 2 to plus pi by 2 minus singleton 0. Fourth is the correct answer. Fourth is the correct answer. These are two. It is the third example, my friend. The domain of the function cos inverse 2x minus 1. In this, I have taken this number other than x. All these are what? It is the domain of sin inverse x, cos inverse x, like that. Even while doing these two, objective type, it is cos inverse x, it is cosec inverse x. But in this case, you wanted the domain of cos inverse 2x minus 1. Cos inverse 2x minus 1. These are the four options given: 0 to 1, closed interval, minus 1 to plus 1, closed interval, open interval, minus 1 to plus 1, closed interval, 0 to 1. Yes, my friends, we know that. We know that domain of cos inverse x. We know that the domain of cos inverse x is minus 1 to plus 1, or your x lies between minus 1 and plus 1. This x lies between this x, my friend. This x number, this x lies between minus 1 plus 1. But what is the change? Instead of x, you have 2x minus 1. For cos inverse x, this x lies between this and this. Instead of x, it is 2x minus 1. Then this 2x minus 1 lies between minus 1 and plus 1. 2x minus 1 lies between minus 1 plus 1. Yes, my friend. Add 1. Minus 1. This is minus 1 plus 1 less or equal to, add 1. 2x minus 1 plus 1 less or equal to 1 plus 1. Simplify 0. 2x. What is this? 1 plus 1 is 2. Then to get x, divide by 2. 0 by 2. 2x by 2. 2 by 2. Therefore, what is the domain? Domain is 0 to 1. Equality is there. Closed interval 0 to 1. Closed interval 0 to 1 is which option, my friends? First option is the answer. I hope the method is clear. We know that domain of cos inverse x. What is the domain of cos inverse x? That x lies between minus 1 plus 1. That minus 1 less or equal to x less or equal to plus 1. Then you wanted, what is the domain of 2x minus 1? Instead of x, it is 2x minus 1. Then this 2x minus 1 lies between minus 1 plus 1. You have to solve and you have to get the x here. For that, first add 1 to each term. Add 1, add 1, add 1. Simplify 0. Simplify 2x. Simplify 2. Then you have to divide by 2. Divide by 2. 0 by 2. 2x by 2. 2 by 2. Then what is the required domain? Closed interval 0 to 1. Which is the correct option? First option. There is one more example. It is also from the exemplar. Domain of the function defined by fx equal to sin inverse root x minus 1. Sin inverse root x minus 1. Root x minus 1. Yes, my friends. For the sin inverse x, what is the domain? Say. For the sin inverse x, the domain is x lies between this number, my friends. This is attachment relation. This number x. It lies between minus 1 plus 1. But in this case, instead of x, it is root x minus 1. First, you must make it clear. This root x minus 1 is defined. That means sin inverse root x minus 1 is defined only when whatever you have inside the square root must be positive or equal to 0. Greater or equal to 0. Then only the sin inverse root x minus 1 is defined. It is defined. Therefore, domain of sin inverse x. In this case, this negative part you can't consider. 0 to minus 1 is not considered. My friends, this is 0. This is 0. This is plus 1. This is minus 1. That is defined only in this interval 0 to 1, but not here. But not here. So it is what? It is what? X minus 1 lies between 0 and 1. X minus 1 lies between 0 and 1. See, 0 less or equal to x minus 1 less or equal to 1. I have written here. Therefore, domain of sin inverse root x minus 1 is, for the negative it is undefined. It is defined only for the positive. This, my friend, 0 to 1. minus 1 to eliminate, add 1. 0 plus 1, x minus 1 plus 1, 1 plus 1. So it is 1, minus 1 plus 1 cancels, it gives x, then 1 plus 1 is 2. Then what about the values of x? It lies between 1 and 2. Therefore, required domain is closed interval 1 to 2. Closed interval 1 to 2 means which option is the answer? Closed interval 1 to 2. 1 to 2 means it is the first option. First, second, third, fourth. First option is the answer. First option is the answer. I hope, my friends, just 2 samples are given. 2 samples. But normally they go for what? Such examples. Such examples. Is it correct? Yes. Even these 2 are good examples of CET or any competitive examinations, my friends. Competitive examples. And they are authorized examples. Why? They are the examples from the exemplar book, my friends. Exemplar is one of the good book for the exam sake. So, sin inverse x domain. The sin inverse root is defined only for the positive values greater or equal to 0 inside greater or equal to 0. Therefore, domain of this is what? This x minus 1 lies between 0 and 1, not minus 1 to plus 1. It lies between 0 and 1. Add 1, this 1 x, 1 plus 1 is 2. Therefore, the domain is what? Closed interval 1 to 2. Therefore, the answer is, this is the answer, closed interval 1 to 2. Yes, my friends. These are 4 examples, little bit multiple choice or objective type of questions. Objective type of questions. I am dealing with only for the your main exam means board exam. So along with this, I have selected these 2 slight different examples, and they are from your exemplar book, my friends. Yes, I'll give 1 minute copy it. Copy. Yes, friends. Yes. All these type of examples comes under 1 mark questions. These are 1 mark questions, my friends. Then I do mixed examples means you may get under 1 mark. Most of the time you may get it under what? 2 mark questions. So I will do mixed 1 mark, 2 mark. These are purely this type 1 mark questions. And these little higher side means CET type of questions. CET or any competitive type of examples. Next 2 mark questions, my friends. 2 mark questions, if you see, they are the examples based on finding the principal value. Finding the principal value of inverse trigonometric functions. 2 mark questions. 2 mark questions. Finding the principal value. My friends, next comes 2 mark questions. Next comes 1 mark, otherwise 2 mark questions. 1 mark, 2 mark questions. They come under what? Finding the principal value of inverse trigonometric functions. Principal value. In this I made it clear, it is a note. The value of inverse trigonometric functions which lies in its principal value branch. The value of inverse trigonometric function which lies in its principal value branch. What is the principal value branch? Respect, you know, the columns. That value in particularly called as what? Principal value of that inverse trigonometric functions. The value of ITF which lies in its principal value branch. Value which lies in the principal value branch. That particular value is called as principal value. That particular value is called as principal value of that inverse trigonometric functions. You need this, man. It is from the previous first year, or even you can say now it is from the 10th standard. 10th standard. You are going to study about all these in the 10th standard. Values of trigonometric ratios of standard angles. Standard angles. These are trigonometric ratios. All the 6: sine, cos, tan, cot, cosec, sec. You know the relation. What is tan? Sine by cos. What is cot? 1 by tan. What is cosec? 1 by sine. What is sec? 1 by cos. For the 0, 30 degrees respect to radians, my friends. 30 degrees respect to radians. Degrees, radians. 60 degrees, radians is pi by 3. 90, this is what? This is pi by 2. This is pi by 2. Pi by 2. Pi by 2. Yes, my friends. My friends. This is sine. Sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. Sine 90 is 1. Cos 0 is 1. Cos 0 is 1. Cos 30 root 3 by 2. Cos 45 Cos 45 is 1 by root 2. Cos 60 1 by 2. Cos 90 is 0. Tan 0 is 0. Tan 30 1 by root 3. This upon this, my friend. 2 cancels, it is 1 by root 3. Tan 45 both cancels 1. 60 this upon this. Again 2 cancels, remains 2 root 3. And tan 90, what is tan 90? 1 by 0. 1 by 0 means what? We can't divide by 0. It is undefined, which is infinity. Then what about cot? 1 by tan. Reciprocal of 0, infinite. Reciprocal of 1 by root 3 is root 3. Reciprocal of 1 is 1. Root 3 is 1 by root 3. Reciprocal of infinity is 0. Then cosec, reciprocal of sine, 1 by 0, infinite. Reciprocal of 1 by 2, cosec 30, reciprocal. Cosec 45, reciprocal. Cosec 60, reciprocal, 2 by root 3. Cosec 90, reciprocal is 1. This is with sec, my friends. Sec 0, reciprocal of 1 is 1. Sec is what? Reciprocal of cos. Sec is 1 by cos. 1 by 1. Reciprocal 2 by root 3. Reciprocal root 2. Reciprocal sec 60 is 2. Reciprocal of 0 is infinite. Yes, my friends. These are the values of trigonometric ratio of what? Standard angles. Just for your sake, I have reminded this list, my friends. I have reminded this list. Oh, how we are using here? See, you know the definition. We know by definition, when x is sine theta, then taking sine this side, sine inverse x equal to theta. Under this condition, x must be between -1 plus 1 and theta must be between -90 and plus 90. Under these restricted conditions, x equal to sine theta can be written as, taking this side, sine inverse x equal to theta. Therefore, my friend, sine theta equal to x gives theta equal to sine inverse x. It is sine theta equal to x gives theta equal to sine inverse x, or sine inverse x equal to theta gives x equal to sine theta. My friend, sine taking this side becomes sine inverse. Sine inverse taking this side becomes sine. Under this condition, what is that condition? This x must be between -1 plus 1 and this theta angle must be between -90 and plus 90. Under this restriction, it is true. My friends, from this, we know that sine 30 is 1 by 2. What is this 30? It is an angle between -90 plus 90. What about this 1 by 2? Lies between -1 plus 1. Then we can take this sine this side. By taking sine this side, it gives sine inverse 1 by 2. But what is it? 30 degrees. So, if you take that side, my friend, this gives 30 degrees equal to sine inverse 1 by 2. Sine inverse 1 by 2. 30 equal to sine inverse 1 by 2. Therefore, sine inverse 1 by 2 is 30 degrees. It is in terms of radians, pi by 6. Second, we know sine 90 is 1. Sine 90 is 1. Taking sine this side, sine inverse 1 is 90 degrees. Sine inverse 1 is 90 degrees. Then, my friends, this drama is not necessary. Directly you are going to write. What is sine inverse 1 by 2? It is a angle whose sine is 1 by 2. It is an angle whose sine is 1 by 2. You must know this angle is what? Corresponding to this number, sine of that angle, sine 30 is 1 by 2. So, what is sine inverse 1 by 2 is that angle 30 degrees. Similarly, sine inverse 1 is what? Respective angle. What is that respective angle? Sine 90 is 1. When sine inverse comes, you have to write only that angle, 90 degrees, or pi by 2 radians. Now we can write direct. Sine inverse root 3 by 2, you can write what is root 3 by 2. It is sine 60. Inverse is there, you write only angle. Cos inverse 1 by 2. In case of cos inverse, what is the respective angle? 60 degrees. Tan inverse 1, what is the angle? Tan pi by 4 is 1. Therefore, tan inverse 1 is pi by 4. Directly you can write. Not like this. Sec inverse 2. What is sec inverse 2? Even you can convert by one property. Cos inverse 1 by 2. Cos inverse 1 by 2 is 60 degrees. Cosec inverse root 2 respective. Root 2 means what? Pi by 4. Now you know this property. Sin inverse minus x is minus sin inverse x. Cos inverse minus x is pi minus cos inverse x. Tan inverse minus x is minus tan inverse x. Like this, my friends. In case of cosec inverse minus x. Cosec inverse minus x is minus cosec inverse x. Minus cosec inverse x. Like that, sec inverse minus x, pi minus. Cot inverse minus x, pi minus. 3 directly minus. Sin inverse, tan inverse, cosec inverse. See. Sin inverse directly minus. Tan inverse outside minus. Cosec inverse is minus. In these three cases, that minus directly comes. In the other three, cos inverse comes pi minus cos inverse. And my friends, sec inverse comes. Sec inverse of minus x is pi minus sec inverse x. Cot inverse minus x is pi minus cot inverse x. 3 direct minus, other 3 are what? Pi minus the respective ITF. Making use of this property in finding tan inverse of minus root 3, apply this property. Minus tan inverse x. Minus tan inverse x. Minus tan inverse root 3. Root 3 means what is the corresponding angle? Root 3 in case of tan inverse, what is the corresponding angle is 60 degrees or pi by 3 along with that minus. Cos inverse minus 1 by 2. It is pi minus cos inverse 1 by 2. In case of 1 by 2, this is cos inverse 1 by 2. What is the respective angle? Either 60, otherwise pi by 3 radians. So it is pi minus pi by 3 to pi by 3. Cosec inverse minus root 2. You have to apply first this. Cosec inverse of minus x is minus cosec inverse x. Therefore, cosec inverse of minus root 2 minus cosec inverse root 2. Root 2 comes pi by 4. See here. Root 2 pi by 4, otherwise 45 along with that minus sign. Minus pi by 4. Yes, my friends. In finding the principal values, we need this chart. Making use of this chart, you know how to write directly the values. By making use of all these and the properties of inverse trigonometric functions, I am going to do one more set of examples. Those set of examples are good examples, mainly first 2 mark questions. Here and there, you may have under 1 mark. Simple examples. Otherwise, these examples on these values are principal values. They come under what? 2 mark questions. Yes, my friends. I write a few properties, simple properties of what? Inverse trigonometric functions. I will remind them. After reminding the properties of ITF, then I am going to do next set of examples which comes under 2 mark questions. Yes, my friends. First I write properties. Yes, my friends. Here I have written just to remind you the properties of inverse trigonometric functions. First, sin inverse of sin theta equal to theta. This is useful only for this restricted interval where it is It is minus pi by 2 to plus pi by 2. Theta belongs to the closed interval minus pi by 2 to plus pi by 2. Cos inverse of cos theta equal to theta. When the theta lies between 0 to pi, 0 to 180 degrees. Tan inverse of tan theta equal to theta, where theta lies between minus pi by 2 to plus pi by 2. Cot inverse of cot theta equal to theta. Theta lies between 0 to pi. And cosec inverse of cosec theta is theta. For theta belongs to, it is a range of what? Cosec. Minus singleton 0. Sec inverse of sec theta equal to theta. For theta belongs to 0 to pi except this, pi by 2. This is first property. This is second property. Sine of sine inverse x. It is sine inverse of sine theta. It is sine inverse of sine theta. Cos inverse of cos theta. But these are sine of sine inverse x is x. For x lies between minus 1 to plus 1. Cos of cos inverse x is x. Same interval. Tan of tan inverse x is x. For all x belongs to R, set of real numbers. Cot of cot inverse x equal to x, for x belongs to R. Whereas for the sec inverse and cosec inverse, x belongs to R minus this open interval minus 1 to plus 1. Open interval minus 1 to plus 1. This, my friends, entire R it is minus infinity to plus infinity. Here x greater than this, x is smaller than minus 1, except these values, this open interval, except this. Entire remaining except this, minus 1 to plus 1. Meaning, then third property, sine inverse of 1 by x is cosec inverse x, or cosec inverse x can be written as sine inverse of 1 by x. X 1 by x, reciprocal, sec inverse of x, cos inverse 1 by x. Cot inverse or tan inverse 1 by x equal to cot inverse x. You can write this only when x is positive. When x is a negative, it is minus pi plus cot inverse x. Minus pi plus cot inverse x. Fourth, very useful. Sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is minus tan inverse x. Cosec inverse of minus x is minus cosec inverse x. These three, directly that minus is outside in these three cases. These are for the values of x. X belongs to minus 1 to plus 1. X it belongs to R and x is greater than 1. Then the other three, cos inverse of minus x is pi minus cos inverse x. Cot inverse of minus x is pi minus cot inverse x. Sec inverse of minus x is pi minus. In these three cases, it is pi minus. In these three cases, direct minus is out. I have written for values of x there. This is the simple property. So I will consider some 2-3 examples, and they are simple examples under 1 mark. Sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Sec inverse x plus cosec inverse x is pi by 2. This is for the values of x. For sin cos minus 1 to plus 1. Tan x belongs to R. And sec and cosec x belongs to R minus that open interval. These are some properties connected with, my friends, ITF. Now I am going to do one set of examples which are important under 2 mark question. So simple example they may give under 1 mark question. Now I am going to do the examples. How to find the principal values that list, my friends, values of t ratios, of trigonometric ratios. That plays a very, very important role, my friends. You must remember. Yes. Now I am going to do some examples, my friends. My friends, I have written a few more examples here. These are the examples in finding the principal value of the following inverse trigonometric functions. For the following inverse trigonometric functions. This is the first. Find the principal value of cos inverse minus 1 by 2. Appeared twice in the question paper, my friends. Twice. We know that cos inverse of minus x equal to pi minus cos inverse x. Therefore, replace your x by 1 by 2. So, cos inverse 1 by 2 is pi minus cos inverse 1 by 2. It is pi minus cos inverse. Either you write directly 1 by 2 corresponding angle whose cos is 1 by 2. You know cos 60 is 1 by 2. Then cos inverse means it is only angle itself. Otherwise, you can write like this. Cos inverse, what is 1 by 2? Cos 60 is 1 by 2. If you are not comfortable with what? Radians, you can directly write with degrees also. Degrees also. I do one example with degrees. Yes. It is pi minus cos inverse of cos 60 degrees. Why? That 60 is an angle lies between 0 and 180 degrees. So you can apply the property. Pi minus pi by 3, which is 2 pi by 3. This is second example. Find the principal value of cosec inverse minus root 2. It is appeared in March 2017. We know that cos inverse of minus x equal to minus cos inverse x. Replace your x by root 2. Therefore, cosec inverse minus root 2 is minus cosec inverse root 2. Then, what is this root 2? Cosec 45. Cosec inverse of cosec theta is theta, as this theta lies between minus pi by 2 to plus pi by 2. Therefore, this is minus pi by 4, the value of this my friend. This is the third example. Find the principal value of cot inverse minus 1 by root 3. Cot inverse minus 1 by root 3 appeared July 2019. We know this property. Apply for this. Replace your x by 1 by root 3. Pi minus cot inverse 1 by root 3. Either you have to write 1 by root 3 is nothing but what? Cot 60. Cot of cot inverse is 60. Otherwise, directly cot inverse corresponding angle whose cot is 1 by root 3. It is pi by 3. Simplification 2 pi by 3. Find the principal value of tan inverse minus 1 by root 3. Minus 1 by root 3. It is minus tan of minus tan inverse x. So, minus 1 by root 3. Minus tan inverse 1 by root 3. That 1 by root 3 is nothing but tan 30. Tan 30. Tan inverse of tan. That angle itself, my friends. This is angle itself. This is minus is there, right? This minus pi by 6. Cos inverse of minus 1, same. Cos inverse 1 is 0. Cos inverse 1 is 0. Pi minus 0 is pi. Sec inverse of minus 2. Sec inverse of minus 2. We know this property. Pi minus sec inverse of minus 2. Pi minus sec inverse 2. But what is sec inverse 2? 2 means 60 degrees. Pi minus pi by 3, which is 2 pi by 3. These are some examples, my friends. You do it yourself. If it is positive, I have done almost all these examples with a negative sign. Instead of that, if it is positive only, like this I take, my friends. I take what? Sine inverse root 3 by 2. Yes, what is it? It is sine inverse. Root 3 by 2 is what? Sine 60 degrees. You wanted to write in terms of degrees. Sine 60 is root 3 by 2. Sine inverse of sine, my friends, it is 60 degrees. It is 60 degrees. Then you can write in terms of degrees. It is with a positive sign. This otherwise directly you can write 60 degrees. Fine. Corresponding angle root 3 by 2. It is an angle whose sine is root 3 by 2. Sine 60 root 3 by 2. So it is directly 60 degrees. Otherwise, root 3 by 2 is sine 60. Sine inverse of sine is that theta itself. You can write like this, my friends. You can write like this. Yes, I give 1 minute, copy it. And all these examples, my friends, you can do. I hope my friends copied all these things. These examples purely under 1 mark, otherwise 2 mark questions, my friends. 1 mark or 2 mark. Then today this much is enough, my friends. It is enough. Yes. Yes. Please do well. These are 1 mark, 2 mark. 2 mark questions of what? Inverse trigonometric functions, my friends. Yes. Enough. Bye. Goodbye. Namaste. Namaskara. My friends. Namaste. Have a good day. Good day.